We have recently seen that if there is a complex number, which is, let's say, there is a complex number which is z is equal to x plus iota y. The same complex number can be written into the form z equal to um, r cos theta plus iota sine theta. Now this is its actual name is the polar form, but in your book it says the modulus argument form, like it's written as the modulus argument form of a complex number. Okay? This can also be written as the same complex can also be written as r e raised to power iota theta. Now this is a very useful and a very strong kind of representation of the complex numbers. One of the uses of writing your complex number in the polar form or in the exponential form is that this makes your multiplication and division and then applying different powers on these complex numbers very quick. Okay? Now, I have to tell you what happens when you multiply two complex numbers in polar form. So just see that. Now suppose you have a complex number which is z1 and this is r1 cos, okay, I'll do that. Cos theta 1 plus iota sine theta 1. And then there is another complex number which is z2. Can you see this? Yes, okay. Now z2 is r2 cos theta 2 plus iota sine theta 2. So we have two different complex numbers. One is z1, other is z2. Z1's modulus is r1 and the argument is theta 1. Z2's modulus is r2 and the argument is theta 2. When you multiply these two complex numbers, you will not have to multiply it like we normally do when we have the complex numbers in this form. So the product's modulus would be the product of the moduli of these two complex numbers. That will be R1, R2. Okay? Then guess what will be the argument of this product here? That will be theta 1 plus theta 2 plus iota sine theta 1 plus theta 2. Okay? Now you have to prove this, that why it is so. Now let's prove that. Let's multiply them. This is R1 cos theta 1 plus iota sine theta 1 multiplied by R2 cos theta 2 plus iota. Now come on, you have to multiply this and you have to prove that this is really what I have written. Okay, you people are trying this and I am going to try this as well. So just keep on trying. This is R1, R2, cos theta 1, cos theta 2. This into this gives me cos theta 1 into cos theta 2. And then this one multiplied by this one, that will give me plus iota sine. I'll be writing the sine theta 2 intentionally first. Then this into this gives me and finally this into this. Okay, if I rearrange this, I will get what is iota square? Minus 1. So this iota square, I have changed that with minus 1. So I'm writing it here. That is cos theta 1, cos theta 2, minus iota sin theta 1, sin theta 2. And then plus iota into I have sin theta 1, cos theta 2, plus sin theta 2, cos theta 1. Okay? How many of you remember that this, I should write it here, that cos alpha plus beta is cos alpha, cos beta, minus sin alpha. Do you remember this? Your cos alpha plus beta is cos alpha, cos beta, minus sin alpha, sin beta. So if you have cos theta 1, cos theta 2, minus sin theta 1, sin theta 2, so that means you can write it as cos theta 1 plus theta 2. Yes? What is your sin theta 1 plus theta 2 or sin alpha plus beta? Come on, Mina, what is happening to you? Yeah. Okay, your sin alpha plus beta is sin alpha cos beta plus sin beta cos alpha. Okay, so you have this sin theta 1 cos theta 2 plus sin theta 2 cos theta 1. So this can be written as sin theta 1 plus sin theta 2. Okay? So that is the first rule over here, that when you multiply two complex numbers, their arguments are added and their moduli, they are multiplied. Okay? So this is really quick. Acha, ab dekhiye, I just want to clear this.
Sir, 2 minute wait करें please.
Okay, I'm waiting. So this is what we have done so far. Now guess if you have to find Z1 over Z2, so what would be that? Okay, R1 over R2 and exactly, very intelligent. This is cos theta 1. Like, please remember the upper's argument minus the lower argument, okay? Plus iota sine theta 1 minus theta 2. And this becomes easier to understand if you people use its exponential form like this. This is same as R1 e raised to power iota theta 1. And this is R2 e raised to power iota theta 2. When you multiply them, this will be R1, R2 e raised to power iota. You see, when you multiply the same basis, the powers are added. So that is why this is theta 1 plus theta 2. And similarly, this is R1 over R2 e iota, and this is theta 1 minus theta 2. Now imagine, bacho, you have a complex number z, or let's say u, which is 5, okay, cos 20 degrees plus iota sine 20 degrees. Can you tell me quickly what will be the complex number u squared? What will be the modulus of this u square? That will be 25, because the way you have done z1 into z2. So when you do that u into u, so the modulus of u is 5 into 5, so that will give you 25, okay? And what will be the argument here? cos 40 plus iota sine 40. Okay, and you can find the square roots much easily, much faster, much quicker if you want to find them through this polar form. Okay, I'll tell you in 2-3 days how to do that. Okay, acha. Now let's go into some questions here and see that how this is being applied in questions. Okay, in this question, your u is 4 cos 5 pi by 12 plus iota sine 5 pi by 12. And your w, let me write this w in the same form. That is 2 cos pi plus iota sine pi. Okay, bachcho? Then he says, find and simplify this uw and u by w. Okay, let's do that. So uw. Tell me quickly, what will be the modulus of uw? A. Good. And what will be the argument? Let me find it here. 5 pi by 12 plus pi. That is 17 pi by 12. I cannot go beyond this pi and minus pi. So this is 1 whole 5 pi by 12. Okay? 5 pi by 12. That means if I look at this, how to determine this? Now, if I go from here, this much is pi, and then further I have this 5 pi by 12. So what will be the argument? Come on. That will be minus 7 pi by 12. You have to be between minus pi and pi. I cannot go beyond pi. Okay. So this, when I added them together, I got 17 pi by 12. So I need to convert that into a mixed fraction. This is 1 whole 5 pi by 12. So look at this. Up to this is pi. Okay. Plus, this is your 5 pi by 12. Now this is going into the lower quadrants. So I have to consider that clockwise argument. Okay. So this is going to be minus 7 pi by 12 plus iota sine minus 7 pi by 12. And I have to write that in, he says write this in the polar form. So I will be writing it as 8e minus 7 pi by 12 iota. Can someone please check the answer? Please check that. In the meanwhile, I'll be doing that u over w. So u over w, what will be its modulus, u over w? 2. That is 4 over 2. So this is 2. Okay, cos. Now, I have to subtract them. So upper one is 5 pi by 12. And then minus pi. So this is minus 7. It is the same, I think. Same argument. So rather than writing this, I'll be writing it as 2 e raised to power minus 7 pi by 12 iota. Can you please check the answer? Okay. So it says find the exact values of the modulus and argument of z. So let's find this modulus of z quickly. So that is the real part squared 16 times 3, that is 48, plus 16, so that is under root 64 So that is going to be 8. And then the argument of z. So that is tan inverse of b over a. And you should always draw the arcane diagram before you find this. So here it is 4 under root 3. And you have somewhere here minus 4. So this is just to confirm that if it is going to be clockwise or anti-clockwise, okay? So that is tan inverse of minus 4 over 4 under root 3. So that is going to be minus pi by 6. Okay? Now, I'll be writing this z in front of it over here, that this z is now 8, okay? And cos minus pi by 6 plus iota sine minus pi by 6. By the way, the same complex number can also be written as 8 cos pi by 6 minus iota sine pi by 6. Are you clear? Why can we write it like this? Come on, yaar. What is cos of minus x? Cos x. And what is sine of minus x? Minus sine x. And what is tan of minus x? Abhi, there's a question coming and this will be used there. Tan of minus x, that is minus tan x. Okay, so why should I prefer this form or this form for the B part? The left hand side form or the right hand side form? देखिए, when you will have to multiply them, look at this. The B part says z over w. So when you're dividing them, you will need to subtract the arguments. So this is going to confuse you over here that if the argument is positive. So if you write this in its actual form, so that there you will not be misleaded over here. Okay? So let's do its B part. Now, if you people allow me, I can say that this z over here, z is, so completing this z is going to be 8. And then, though I have written it up there, cos of minus pi by 6 plus iota sine of minus pi by 6. Okay? So, and your w is 2 under root 2 cos pi by 12 plus iota sine pi by 12. Can you tell me mentally that what will be the modulus of z over w? Yeah? That is 8 over 2 under root 2. And then you can rationalize it. Like if this is 2 4s are, so you can multiply this by under root 2 over under root 2. Okay, anyhow, let's see. Now what will be the argument of this z over w? Yeah, you will be adding them together. So let me just write it down. Cos of minus pi by 6 plus, yes, beta? Oh, we had to subtract, yes. So minus pi by 6 minus pi by 12 plus iota sine minus pi by 6 minus pi by 12. Let's see what is this minus pi by 6 minus pi by 12. Minus 5 minus 3 pi by 12, that is minus pi by 4. So this is going to be 2 under root 2. And let me write in this form as he wants us to write, okay? So that is going to be e raised to power minus iota pi by 4. That is the required answer over here. So you must realize that we are using this polar form to multiply or divide these given complex numbers.